It's been 5 years since NASA launched its Juno spacecraft back in 2011, and its 5-year track is nearly over. Launched in August of 2011 on a mission to investigate Jupiter's structure, composition, and formation history, this particular probe is about to make an appearance on July 4th of 2016. In this video, we're going to briefly talk about this mission and explain what's so important about it. Welcome to What the Math. So July 4th is the Independence Day in the US. It's going to be a big celebration, but it's going to be an even bigger celebration in NASA because their probe that's been around space for like 5 years now is about to basically achieve a stable orbit around Jupiter and start its 2-year mission. It's a very exciting and very innovative probe, and it's basically going to be arriving into the Jovian system to explore Jupiter and to learn about it. Now, this particular probe left in 2011, but it actually had to do an Earth flyby 2 years later just so it can use a so-called slingshot maneuver to get extra speed so that it could actually reach Jupiter. So in order to not waste too much fuel, they actually decided to spend extra time in space for that extra maneuver, because it actually uses quite a lot of really heavy machinery on board, meant to both protect it from Jupiter's radiation and also to basically produce a lot of energy using its very large solar panels. Now, on July 4th, this probe is going to use its hydrazine engines for about 35 minutes to essentially slow down and enter a relatively elliptical orbit around Jupiter. So obviously it's not going to use any kind of air braking that you may have used in Kerbal Space Program, because here air braking would basically destroy this probe completely. And after this, it's going to spend around 30 orbits around Jupiter, with each orbit being approximately 14 days, and use its 9 science instruments to essentially study the planet's composition, its magnetic field, its gravity field, and prove a few theories or possibly discover new things about Jupiter. And really the main goal for this mission is to essentially learn the recipe of the solar system, because if we can actually find out how Jupiter was made, we can use this understanding to find out how Earth and Mars were formed, and also possibly even where life on Earth came from. And to answer this, we basically need to first learn how much water is inside Jupiter, so we're going to study all of this, which should essentially yield the answer of how much water was actually present in the early solar system as well. And one of the ways they're going to do this is essentially by measuring the ratio of oxygen and hydrogen present in Jupiter's atmosphere. And also we're going to try to find out if Juno actually has a rocky core, or if there is something else on the inside, because right now the assumption is that it has a core several times more massive than Earth. And so there's a lot of really cool questions and answers we'll actually have after the end of this mission. And this is kind of cool because Jupiter is actually the oldest planet to have formed, so if we can discover what's on the inside, we'll be able to understand our solar system a lot better. Now, we're actually going to also talk about some fun facts that you may have not known about this particular mission or Jupiter in general. And the first fact here is actually the name of Juno. And originally it stood for Jupiter Near Polar Orbiter, but actually Juno is also the wife of Jupiter. And mythologically, Jupiter actually created a veil of clouds around himself to basically hide his mischief from his wife. And his wife Juno was able to peer through the clouds and see Jupiter's true nature, specifically his many lovers. And if you don't actually know, many of Jupiter's moons are named after Jupiter's lovers, including obviously Callisto and Ganymede. So his wife is actually coming to check up on him, which is kind of funny. And number 2 fact here is in regards to Jupiter's incredibly strong radiation. Now, one of the reasons why this probe is going to have a very elliptical orbit is because the magnetic field of Jupiter is about 20,000 times stronger than a magnetic field on Earth. And because of this, it actually produces Van Allen's belts, very similar to the ones on Earth, but obviously much stronger, with incredibly strong radiation. And often on Earth, we actually use relatively thick shields to protect our satellites and obviously our capsules with people inside from Van Allen's radiation. On Jupiter, this has to be much bigger because the radiation here is incredibly strong. As a matter of fact, it's thousands of times stronger than radiation on Earth. So if this was actually a person flying in this capsule, this person would probably not survive for a very long time. And so to protect Juno from all of this, it's essentially kind of like sitting inside a car-sized titanium safe. And this vault will basically protect Juno from this radiation when it's a little bit closer to the planet and when it's experiencing these really strong magnetic and radioactive fields. And interestingly, Jupiter's magnetosphere is so big that it actually extends almost to the orbit of Saturn, so it's actually relatively huge. But what's actually even more interesting is that Io, one of the moons of Jupiter, is actually somewhat responsible for the shape of this magnetosphere. And so because of Io's eruptions and because it often releases quite a lot of various sulfur dioxide compounds, this sulfur breaks into these two very strong ions called sulfur plus and oxygen plus ions, and they turn into something called plasma. And this plasma actually orbits around Jupiter, creating a relatively thick and relatively hot donut shape, which then kind of influences how the magnetosphere around Jupiter is shaped. And this donut shape is actually somewhat close to Io's orbit and is ridiculously hot. It's something like 100,000 to 1,000,000 degrees hot. So if we were to fly through this, we would obviously kind of melt almost right away. And so because of all of this, Juno obviously has quite a lot of protection and is a relatively heavy craft as well. Alright, so fact number 3 here is that Juno is actually made using really old computer called RAD 750, and this is once again because the high radiation in the Jupiter system, in Jovian system, is essentially so strong that any other computer would probably melt or stop working, and so NASA decided to use something that they know works in high radiation. And so they use a computer that's much weaker than your smartphone, and much weaker than your laptop, and this is because it's known to survive in these really tough conditions. And so both its memory and also its processing power is relatively weak compared to any modern computer. And fact number 4 here is that Juno is actually using solar panels to power up, and these panels are the largest panels ever produced, and that's because it is actually the farthest craft to have ever used solar panels so far away from the sun. Now, when any kind of a probe makes it so far in our solar system, usually they use plutonium-based batteries, but unfortunately, because they're more expensive and because we actually don't have that many left, we had to rely on something else. And so the scientists at NASA decided to invent these new, relatively cheap and relatively big solar panels that are essentially placed in this triangular configuration around the craft that will produce just enough energy to power this craft for several years. But interestingly, its power is actually not very high. As a matter of fact, if you have a blender at home, it uses a lot more power than these batteries can produce. So all in all, these 9-meter long panels, even though they look pretty powerful, don't actually produce that much electricity. And fact number 5 relates to the very elliptical orbit of Juno, and this is once again because NASA wants to minimize exposure to radiation nearby. And the orbit here, that will take approximately 14 days to move around the planet once, is going to have its periapsis, or the closest approach, at 5,000 kilometers, but its farthest approach, its apoapsis, is going to be at 2 million kilometers. It's actually even farther than Callisto, the satellite of Jupiter, that's approximately 1.2 million kilometers away. So the orbit here is going to be relatively interesting, and it's going to be a polar orbit so that we can actually map the entire surface of Jupiter. And fact number 6 is that Juno will officially end on February 2018, and the ending is going to be quite dramatic. It's essentially going to plunge into the atmosphere and destroy the craft in a very unusual and very interesting fashion. And there's 2 reasons for that. One is that because we actually want to measure some of the thicker layers of the atmosphere right before the craft craft is destroyed, and 2 is because we actually don't want to contaminate nearby objects with potential bacteria that may have actually stowed away on the craft when it left Earth, because if one day we land on Europa or if we land on Ganymede and we discover bacteria there and they're actually from this craft, it's going to be a bit of a bummer. And lastly, fact number 7 is actually, it relates to something that's already on board of the craft, and so there's 2 things that are actually interesting. One of them is a plaque produced by the Italian Space Agency, and it's essentially Galileo's own handwriting that he wrote in 1610 when observing what later would become Galilean moons. Essentially, it's the 4 biggest objects, 4 biggest moons orbiting around Jupiter, and so here it's Io, Ganymede, Callisto, and Europa. And what he wrote is this: on the 11th, it was in this formation, and the star closest to Jupiter was half the size than the other, and very close to the other, so that during the previous nights, all of the 3 observed stars looked of the same dimension, and among them equally afar, so that it is evident that around Jupiter there are 3 moving stars invisible till this time to everyone. And the stars here refers to are obviously the moons that we know today. And also on top of that, there are actually 3 Lego figurines representing Galileo, the Roman god Jupiter, and his wife Juno. Interestingly, these are not made of plastic, they are actually made of aluminum, because plastic would obviously not survive in these conditions. But interestingly, because they will actually plunge into the depths of Jupiter, we don't really know what's going to happen to them afterwards. They might melt, they might actually remain, and maybe one day some kind of a future civilization will discover them and think that these tiny creatures are actual remains of human explorers. For all we know, that could happen, right? Anyway, that's all I wanted to mention in this video, and hopefully you learned something about the Juno mission that arrives for me technically today, for you in the past, and I hope you'll subscribe if you still haven't, you'll share this video with your friends, and like this video if you've enjoyed watching it. In the next video we'll talk about something else related to math, space, sciences, or something completely different, and hopefully you learned something else from those videos as well. I'll see you guys in the next video, game you later, and as always, bye bye.